Hi everyone. Today we're going to learn about Mttr, Mtbf, Mtta, and Mttf and see how these terms are related to each other. Now, Mtbf stands for mean time before a failure occurs in a system, and it affects the reliability as well as the availability of a system. So let's understand this with the help of an example. Let's say we have a coffee machine, and the prime responsibility of the coffee machine is to prepare coffee for us. And the failure in the coffee machine occurs when it runs out of milk. Okay, and again it becomes healthy when milk is refilled. So let's take an example of a timeline. Now let's say at 1 p.m. the coffee machine started working, and let's say at 5 p.m. the coffee machine ran out of milk, and again at 6 p.m. let's say the coffee machine was refilled with milk again and it started working fine, and at 9 p.m. let's say again the coffee machine ran out of milk, and let's say at 10 p.m. it was again refilled and it started working again properly. Now what is my Mtbf in this case? So Mtbf is basically mean time between failure. So let's say we had two failures, so it basically refers to your average uptime between two failures. So here we had one failure here and the second failure here. So the average uptime here is basically your total uptime divided by number of failures. Now total uptime here in our case is 4 hours between 1 p.m. and 5 p.m. when the system was up, okay, and 3 hours when the system was up between 6 p.m. and 9 p.m. and the total failures were 2. So our average uptime between these two failures is basically 3.5 hours. Okay, so this becomes your Mtbf for this scenario. Okay, now Mtbf is directly proportional to reliability of a system. What is reliability? So reliability is the ability to consistently perform in a healthy manner for a system. Okay, so greater the Mtbf, better the reliability and better the system. Okay, so we need to achieve a higher Mtbf for any systems. And how can we do that? Now, one is you have a fault tolerance in your system. Okay, you have circuit breakers in your system. Okay, now let's take an example. Let's say you have a server and it is connected to a database. Now, if this database goes down, your whole server goes down because it's not able to access the data. Okay, so then in that case you can have fault tolerance in terms of you have primary database and secondary database, and you have a switchover mechanism that if primary falls down you have secondary, so that your server is still up to cater to the request of the clients and your average uptime increases. Okay, so this is your Mtbf, that is mean time before failures. Now let's understand what is Mtta. So Mtta stands for mean time to acknowledge, and it affects the responsiveness of the system. So let's take the similar example. Let's say at 5 p.m. your machine ran out of milk. So the last person who would have accessed the machine would be at 5 p.m. for this particular slot of milk. Now when the milk ran out, let's say at 5:30 this machine was out of milk, and at 5:30 a user came and he saw that the milk is not there. Okay, then he went and informed the maintenance guys that the machine has ran out of milk. So this is the time when the users came to know that there's a problem in the system. They acknowledged the problem in the system, that the system has run out of milk, the coffee machine has run out of milk, and this is basically my Mtta, that is basically time to acknowledge. Now what is mean time? So mean time will be your average of all the times to acknowledge. So let's say at 5:30 you came to know that your milk has run out. Basically a user came and he poured the coffee and he saw that the milk is not there. Similarly at let's say 9:40 here a user came and he saw that okay, milk is not there, so they informed the maintenance guys. So in both the cases, for one failure the time is 30 minutes when the problem was acknowledged, and for the other failure the time is 40 minutes when the problem was acknowledged. So the Mtta, mean time to acknowledge, is basically total time taken to acknowledge all the failures divided by number of failures. So in our case it is equal to 30 minutes in one case and 40 minutes in the other case. Okay, divided by 2, which is equal to 70 divided by 2, which is equal to 35 minutes. Okay, this is my mean time to acknowledge. Now in case of mean time to acknowledge, it is directly proportional to your responsiveness of the system. So better is having a lower MTTA for a system. So how can we achieve that? Now in case of MTTA, okay, you have to make sure that the user knows about the problem first, and then the system also knows about the problem. And the better is that the system knows about the problem before the user knows, so that you can react quickly. So let's say you have a server, okay, and basically there's a let's say an HTTP client, HTTP server running, and we have a client. Okay, so the client can make calls to this server. So when the client basically makes a call to the HTTP server, the HTTP server gives a success or a failure response. Now if the HTTP server goes down, the HTTP server will not directly go and inform, or the client will not be able to know unless and until the client has made a call to the HTTP server. Okay, so in this case, the client has to keep polling that whether my system is up or not, okay, or do a health check on the system, okay, to check the liveliness of the system. Okay, now in other cases, let's say so in this case, if the client lets you know that your system is down, it might happen that on the timeline your system went down at time t1 and the client polled the system at time t2. So for this time you were not known, you did not knew about that the system was down. So better is the server itself knows that it is down. So in such scenarios, we have to introduce metrics in our system. Okay, we can have Prometheus servers or Datadog, which constantly polls the servers internally, and it knows whether all the systems are working fine or not. Okay, and then on top of that, you can have alerting mechanism. Okay, if there are two systems that are basically, let's say, tied via a long-lived connection, or whether a TCP connection or a web socket, so they can, what they can do is they can periodically send heartbeats. So just to make sure that the route is enabled and the route is not inactive, they can send heartbeats and they can acknowledge the heartbeats between each other, so that they know that the connections are up and running. Okay, and in case of HTTP servers, a one-way communication, you can just let the clients know that you can check for the health checks and enable the health check APIs on the HTTP server. Okay, now let's talk about the third term, that is mean time to repair, that is Mttr, and it affects the maintainability of the system. So let's say at 5:30 you came to know that the server was down. At 5:30 you came to know that in the coffee machine the coffee was not there. Okay, so between 5:30 and 6 p.m. you take 30 minutes. The maintenance guys took 30 minutes to fill the coffee in the machine, the milk in the machine. And similarly here, between 9:40 to 10 p.m. they took 20 minutes to refill the machine with the milk. So basically the time taken to repair, okay, basically it's the time between which your system comes up and running and when your system was basically notified, when you came to know about when there's an issue in the system. That's the time which represents the repair time. So the average repair time is basically total time taken by all repairs, total repair time, divided by number of failures. So here in our case it's 30 minutes plus 20 minutes divided by 2, which is nothing but 50 minutes divided by 2, which is 25 minutes for us. Okay, this is your mean time to repair. Now when I talk about mean time to repair, we have to keep it as low as possible, because it shows the maintainability issues in your system, like how much time you're taking to repair your system. So it should be as low as possible. Okay, now what can we do? So first thing is you have automated systems, okay, so that even if an error occurs, okay, you automatically repair your system. So your system should be capable of self-repair. Okay, self-repair. Now again, the example wherein we took off primary and secondary database servers, wherein the switchover can happen automatically, is something which you can consider here. Also, you should have proper SOPs mentioned. You should have proper alerting mechanisms. Okay, when an alert comes, right, you should have proper SOPs, run books, which guides the operators as to what steps they should take so that the system comes up again, and it should be clear and concise and well tested. Okay, now when I talk about Mtbf, it's basically represents your uptime. While I talk about your Mtta, it represents your downtime, the time when the system was not available for the users. And Mttr also represents the downtime when your system is unavailable for the clients. Now, when I talk about availability, okay, any availability of a system, availability is basically the percentage of time when your system was available for the user. Okay, so it denotes uptime divided by total time, percentage of time when your system was available for the user. So it's basically nothing but uptime divided by uptime plus downtime, that denotes your total time. So it can be referred as Mtbf. Okay, it refers as Mtbf divided by Mtta plus Mttr plus Mtbf. So this is your uptime, this is your uptime, and these two are your downtime. So it basically burns down to your availability of your system. Okay, now when we're talking about availability of any system, right, we always talk about a number of nines that your system is up in. Now when I talk about number of nines, right, it can be 5 nines, 4 nines, or even 6 nines, 7 nines, 3 nines, 2 nines, etc. Okay, now if I talk about 5 nines, you can feel that the 5 nines are a lot. Okay, 99 point, let's say 999, so 99.999. 4 9 is 99.99, 3 9 is 99.9, and 2 9 is 99%. So if you talk about 99.999, you can feel that this number is a lot, but in terms of systems, if you calculate in terms of the number of days, so in 365 days, if a server claims that it is 5 nines, it's having an availability of 5 9, it still has 5.256 minutes of downtime per year. And if I talk about 99%, it has this one has 5.256 minutes, this has 5.6 minutes, and 5.256 minutes, which is equal to 3.5 days. So let's consider a bank wherein the transactions are happening. So even a downtime of 5.225 minutes can be a lot, and it can affect the revenue of the bank in terms of like thousands or millions of dollars. Okay, so it's not a lot, what I just wanted to confirm. And how you can learn this, you just need to learn this figure 5.256 and just place the decimals, keep placing the decimals one step ahead as and when you are going down the lines. Okay, now let's talk about now what is Mttf, that is mean time to failure. Now mean time to failure is equal to Mtbf when your system is recoverable. Okay, what do I mean by that? So mean time to failure is basically the total time, the average time a device takes before failure, which are non-recoverable. So it basically is meant for non-recoverable systems. What do I mean by non-recoverable systems? So let's talk about, let's say you have a hard disk. You have a hard disk and it fails. So you cannot recover the hard disk, you cannot fix the hard disk, it's lost, it's gone, and it's counted as the, let's say, a number of writes. So let's say it claims that you can write each number of writes. You can say that it can support, let's say for example 5,000 writes. Just taking a rough example, let's say you take a CFL bulb, and the bulb claims that it is going to work for 1,000 hours. Okay, so this 1,000 hours becomes your Mttf. Basically, after these 1,000 hours, on an average, the bulb will stop working and you cannot recover the bulb. whereas Mtbf refers to your average time uptime before a failure happens, and these failures can be recovered, while as in case of Mttf your failures cannot be recovered. Okay, so with this we conclude the performance metric section, and I would highly recommend you to go through all of these videos and understand them, that what do they mean. We're going to use these terms throughout our lecture series. Okay, and so yeah, that's it for today's video. Thank you.